Now we'll solve a problem on recurrence relation. I'll read a question. The following data relates to the number of defective items in a sample of 5 for 500 samples taken during a week. So here total 500 samples were taken during 1 week and a sample of 5 each. So a sample contains 5 items, total 500 such samples were taken here. And in each sample, how many defectives are identified or observed? That frequency distribution, observed frequency distribution is given here. First, number of defective items. So number of defective items. So since we are taking 5 samples, in each samples 5 items we are taking, so n takes 5. So small n takes 5. So that means the range here x is equal to 0 to 1, 2, 3, 4 and 5. So 0 to 5 is the range. And the next column, number of samples. So how many samples contains? 0. So 0 mistakes contained by 168 samples. That means 168 samples have no defects. Then 180 samples have 1 defect. Then 120 samples have 2 defects. Like that, 2 samples have 5 defects. So with help of this, we have to fit a binomial distribution to the data, obtain the theoretical frequencies. So here they are asking to fit the binomial distribution for this observed frequency distribution. So let us consider here x. X is a number of defective articles or items in a sample of 5. So out of 5 samples, how many are defective? That is considered as a random variable, x random variable. So x tends to binomial distribution. We know n is equal to 5, where p we have to identify. We don't know what is p here. Next, how to get p? So simple. First here identify the mean for given observed frequency. So that is mean for binomial distribution is np is equal to x bar. So mean for binomial distribution is np and mean for common data is x bar, and which is given by summation fx divided by n. So first we need to identify the mean, then we can identify next theoretical frequencies. For that, let us calculate fx first. 0 into 168, 0. 1 into 180, 180. 2 into 120, 240. 3 into 20, 60. 4 into 10, 40. 5 into 2, 10. So total here 530, and total for frequency column is 500. Since 500 samples we have taken here. So mean x bar is equal to np is equal to 530 divided by 500 is equal to 1.06. So mean np is 1.06. Then we know n, that is 5. So p is equal to 1.06 divided by 5 is equal to, so is equal to 0.212 we get, because n is equal to 5. So we know that n is 5. So p value is 0.212. Now next thing is to identify the theoretical frequencies. So to identify the first theoretical frequency, we have to identify p P of 0 first. So here the Px formula for first, always T of 0. For T of 0, use the formula here, n into P of 0. Then for recurrence relation, T of x is equal to n minus x plus 1 divided by x into P divided by Q into T of x minus 1. So here for T1, here T0, for T2, T1, like that. Here if we calculate, we get remaining frequencies. So first let us calculate P of 0. So PMF is equal to P of x is equal to NCx into P raised to x into Q raised to n minus x. So P of 0 is equal to n is 5 5C0 into P is 0.212 raised to 0 and into Q is 1 minus P. So 1 minus 0.212 is equal to 0.788 raised to 5 minus 0. So here P of 0 is equal to 5C0 is 1 into 0.212 raised to 0 is also 1 into 0.788 raised to 5 minus 0 is 5. So we get 0.3038. 0.3038. So P of 0 is equal to 0.3038. So first probability term T naught. So T naught is equal to n into P of 0. So n is 500 into 0.3038. So 500 into 0.3038 is equal to 151.9, approximately 152. So in theoretical frequency tells that 0 defective are got by 152 samples. 152 samples have 0 defective. Now next frequencies we will identify with help of recurrence relationship formula. Let us calculate them. So next T1 is equal to n is 5 minus x is 1 plus 1 divided by 1 into P is 0.212 divided by 0.788 into T of 0. T of x minus 1 is T of 0, that is 151.9. 151.9 will take, don't take a round off value here. So we get, so remember one thing, this value will not change, this value will remain same. So I will identify that 0.212 divided by 0.788 is 0.269 P divided by Q, 0.269. So this value is constant for all recurrence relationship. So here 5 minus 1 in plus 1, so it will remain 5 divided by 1 is 5. So 5 into 0.269 into 151.9 is equal to 204.31. So approximately 204. So 204 samples will have one defective. Next T of 2. T of 2 is equal to 5 minus 2 plus 1 divided by 2 into 0.269 into 204.31. So 5 minus 2 is 3. 3 plus 1, 4. 4 divided by 2 is 2. So 2 into 0.269 into 204.31 is equal to, we get 109.92. So approximately 110. Approximately 110. Next, T3, fourth probability theoretical distribution. So 5 minus 3 plus 1 divided by 3 into 0.269 into 109.92. So 5 minus 3, 2. 2 plus 1, 3. 3 divided by 3 is 1. So 1 into 0.269 is 0.269 into 109.92 is equal to 29.568 is 57. Okay, so next is 29.5 is there, so I will write 30. Next, T4, 5 minus 4 plus 1 divided by 4 into 0.269 into 29.57 is equal to, so 5 minus 4 is 1, 1 plus 1, 2, 2 divided by 4 is 0.5. So 0.5 into 0.269 into 29.57, we get 3.977, that is 98, approximately 4. Approximately 4. And finally, last theoretical frequency, T5 is equal to 5 minus 5 plus 1 divided by 5 into 0.269 into 3.98. So 5 minus 5, 0, plus 1, 1 divided by 5. So 1 divided by 5 is 0.2 into 0.269 into 3.98, we get 0.214. So approximately 0 only we will get. So first let us total it. 152 plus 204 plus 110 plus 30 plus 4. So 500. So that means here this last frequency, that is defective. All 5 are defective. So in the 0 samples we get 5 defective items. So total is 500. So this is the method by which we can get theoretical frequencies. So you can observe here observed frequencies. So 0 defective, 168 samples have 0 defective, whereas in theoretical frequency 152 samples are having 0 defectives, and it tells 204 samples have 1 defective, whereas observed tells 180 samples have 1 defective article. So this is how we fit binomial distribution for a given observed frequency distribution. And this will once again repeat in the chapter chi-square distribution, where we are fitting binomial distribution and we are comparing with observed and theoretical. So you can observe the difference here. So observed frequencies are telling something and theoretical frequencies are telling something. So lot of differences here. And that can be identified there, whether this distribution is good fit or not. So for given distribution, binomial distribution is good fit or not, that will be identified, checked in the hypothesis chapter, that is chi-square test.